Hi, everyone. Thanks so much for joining us. It's going to be a really exciting session today, and we'll kick it right off. I'm very excited to have Brian Ahern here today. Brian's the CEO of DotProduct. He's led the company for over 10 years. He has lots of experience in laser scanning, reality capture, a true expert, and also served in the Navy for a long time. And actually, I just learned right before this, we started here today, that his whole family is a Navy family. So really a good fit for today. My name is Greg. I'm the Shipbuilding Solution Evangelist for SSI. I showcase our innovations. I tell the story of successes in the industry and more things like that. So, Brian, why don't you give people, for those of us who aren't as familiar with DotProduct, just a bit of an overview about who you are and what you do?
Sure. Thanks, Greg, and thanks for this opportunity. I would probably say that technically there's better experts within our company than me, but I'm happy to share my experience at a high level for what we've done, and what the company's about, and what we've done, and what we are continuing to do in the shipbuilding, ship repair industry. DotProduct is a global team of dedicated software innovators. We've been dedicated to making the capture and management of the 3D digital twin easy and efficient. And we're doing that primarily by integrating our state-of-the-art core technology, which is software, with commercial, off-the-shelf 3D sensors and mobile tablets and phone systems as well. We've been doing this for about a decade now, mostly with external sensors attached to Android and Windows devices. But most recently, at the end of last year, we introduced our product over to iOS for the iOS devices that are powered with a LiDAR camera. And so that's been a big change, and also included a big change to our core technology and update to that as well. We've been doing shipbuilding. We've been involved in the shipbuilding and repair business pretty much since we introduced our first product. So it's been about a decade now that we've been involved in the industry.
Yeah, I know we're going to learn a bit more about that later too. So thanks for that.
All right.
But before we get into shipbuilding, I did want to set the stage a little bit about what's going on in the world of reality capture and laser scanning. So mining and geotech, quite large scale. You see laser scanning being used there, but there's not as much need for complex geometry, and there's a lot less of a interaction between elements, so to say. In AEC, we see similar verification type use cases to shipbuilding, again, quite widespread, but there's fewer tight spaces and less need for kind of truly complex detail at a small scale. And the projects themselves are a lot less complex than shipbuilding projects. There's less information, less pressure rather, to use information for follow-on buildings, as in shipbuilding, for example. And in the automotive space, we're seeing it used a little bit, mostly for kind of prototyping and digitization of clay models, for example. Again, this is kind of small scale and not really used for things like as-built verification or as a true part of the engineering lifecycle. So what about shipbuilding? I thought I'd actually ask our audience here today about if they're using laser scanning and reality capture in their shipyard design office. So I'm going to put up a little poll here. We'll just take a minute. I think this is going to be an exciting kind of temperature check of where we're at today, and it kind of helps us tailor our presentation a little bit for our audience too. So far, it's pretty even. We'll give people a couple more chances to vote in there. And actually, one of the interesting things is that there's no good research available yet on what percentage of companies really are using reality capture and what percentage are exploring. And so this will be our own little data point that we can point to after the fact. So from our responses, it looks like about 2/3 of you are already using reality capture in your shipyard or design office. That's actually more than I expected. So this is going to be, I think, an interesting session. I think we're going to refresh some of the things that you already know, maybe. But I think both for those of you who are using it and who aren't using it are going to have some takeaways today about how you can improve your processes and maybe look towards the future. So yeah, in shipbuilding, we already have the powerful software and hardware available to us. I think our poll kind of shows that, yeah, this isn't a new technology. I have a little snippet here from Newport News Shipbuilding, where over 10 years ago, they were exploring and already using reality capture in their workflows, kind of at the cutting edge at that time. And we're also seeing the shift towards more and more organizations owning their own scanners. So instead of hiring third parties or maybe just working exclusively with contractors, now shipyards and design offices have their own scanners and more importantly, have their own experts who know how to use the scanners and actually introduce that into their workflows. So that's kind of the state of things today. And we're going to dive into more of the future and some of these myths. And this is why everyone's here, right? So what are these myths? Myth number one is it's difficult to get started. I think this is something that we hear a lot for those of you who aren't using laser scanning yet. How do I get started? Well, what's stopping you? What are kind of the blockers ahead of you? And what would prevent you from getting started on that journey? There's kind of the fear of equipment. So owning it, the bulky nature of it, maybe the expense of it, right? There's the need for personnel. So either just purely having the person power to actually scan and take advantage of those scans and manipulate them and manage them. It might just be a personnel count issue, so to say. And then there's the training side. So maybe you do have the people there. Maybe they're skilled, they're ready to go, but how do you get them started? How do you get the training and actually introduce and implement this technology? So Brian, I'd like to pose to you the question, what's the reality of kind of scanning accessibility and where's the industry at right now?
Well, it's never been more accessible. I will say that since I first became involved. I first became involved with 3D scanning over 2 decades ago. It was right around 1999, 2000. My previous company, Bitwise Solutions, we had software that integrated with laser scanners for combining it with CAD. At that time, it was about $150,000 for a tripod-based laser scanner, and it might have collected about 400 points per second. Now, today, you have both tripod-based scanners that have come down incredibly in price to probably a third of that, depending on the scanner, plus or minus, let's say, $10,000. They're collecting in excess of 2 million points per second, measurement points, and they're easier to use. It's easier to combine data, various scans. In addition to that, we now have, largely driven by the autonomous robotics and vehicle business, the gaming business, we have new 3D sensors that are even more economical. Now, they may not be able to see 100 meters, but they're very inexpensive. And as mentioned, even today, that some of them are built into mobile devices like the iPad and iPhone Pro. These are relatively inexpensive. Even the ones that are external are a few $100s to put on the back of a tablet or a PC. In addition to all this, the power of the mobile devices has increased exponentially over the years. So what we would have called a supercomputer 20 years ago, you're now carrying in your pocket. And combine all those together, it makes 3D imaging very, very accessible. And depending on your needs, what you have in your pocket won't do everything, but it definitely and hopefully will be able to emphasize this. It should be something that you could at least consider in your toolbox. Yeah,
and I think right now we're going to get a quick look at that toolbox, so to say.
Exactly. So we had hoped to do what you're seeing here is the screen of probably from the iPad. We had hoped to do a live presentation from the iPad, but the webinar, as you know, software couldn't do that from an iOS device. So what we're showing you is a video, and we just pressed that button and started scanning. And you can see we're capturing and building the scan in color as we're going. And this is we put a little haze gray floor in there to make it look a bit more like a ship, some pipes, but it is in a basement facility. And it's just simply walking around and capturing we're capturing frames of data as you're going and building the 3D recognized an April tag in the scene. That is an optional feature that we highly recommend. April tags can be used for a number of things, targeting, accuracy. It also helps with loop closures within your scene. And so that is something that we have in Dot3D, and you see it's recognizing some other April tags over in the other side of the room. And so what we'll also show here is the ability to capture high definition photos, and we're doing that right now just by pressing the camera button and releasing. We're capturing a photo from the camera on the tablet, and measurement is being shown as well. You can add data. You can set your own classifications. All of this can be exported to a CSV or a JSON file as well for use within your system. And it can be multiple annotations, multiple photographs, as we've said. Here we're just saving the pipe as a point on the pipe. And as you can see, there's a list of the annotations. And finally here, we're showing the ability to crop, again, doing this on the device. We do have a tool that is an inexpensive tool to do this on a Windows tablet, a Windows desktop or a laptop. So if you prefer to do this not on your tablet or your phone, of course, then you can do that. And you take the file over and you can do all of these features except for the scanning on your desktop. But here we're doing two things. The red, we're actually cropping. What you saw in the blue or the bluish is just being hidden. So you can bring that back very easily. You're not actually cropping it. So we can both hide and crop with our cropping feature. This is looking at the photos that were taken, and just by pressing on the thumbnail, we're able to see the high resolution photographs. And before that, it was, you see those frustra in the scene. They're little conical, type shapes. That's showing where you were, where you took the HD photographs. And then these are the export formats that we have from the data. So we export to all the standard point cloud formats. We are creating a point cloud. Now our point cloud is highly compressed, and we have over 30 partners, including SSI and Autodesk, that read our compressed file format directly. So it's because it is so move in that format. But if you want to write from the tablet or from your desktop, you can export into these formats, and it may most likely will increase the size of the file quite a bit.
Yeah, I was actually watching the clock there, and it looks like this was real time too, not a sped up footage.
It is very quick. It's a smaller scene, but even in larger scenes, you're talking seconds, usually maybe a minute or two, if that, for a very, very large scene.
So certainly, in terms of ease of getting started, I think that's a good showcase of, yeah, it is easy. You can kind of just get started, and you have a point cloud ready to go and introduce into the rest of your workflow within a few minutes, depending on the size of your scene. So I think that definitely debunks the first myth.
I hope so.
Myth number two, though, is that a scan provides a perfect 3D model. We even hear sometimes that people are kind of equating the scan as being the digital twin, or maybe being the 3D model. But I think, especially in shipbuilding, that's not the case. So we're going to debunk that one as well. Often with, or actually entirely with the laser scan, you really don't get associated metadata as often. Brian showed some great annotations and features like that. That does stay with the scan, but things like the weight of an object, for example, you're not going to capture that through a laser scan. And you can only scan what's visible as well. So handheld scanners are really helpful with that. You can look around corners, get into confined spaces where a tripod scanner won't. But again, there are limitations there. So the key is to really focus on your use case, and that'll tell you that'll be able to get you to what you really need and get you to the best combination of scan and model and digital twin that you need. So, for example, as-built verification, that'll have different requirements from a refit. Scan data, it'll often need to be converted into mesh models if you're working with it and planning to use it for further work. And often it's easier to just reproduce that using simple geometry and then convert that to an intelligent part for use in your actual larger product model. And so the key is to focus on the use case and really understand what your end goal is and what you're trying to get out of it. So Brian, why, I kind of touched on it a little bit, but why handheld scanning? What are the benefits to that?
Well, one is it's inexpensive. And so it makes it easier to get into the technology. In fact, many of our customers have started out in multiple industries, have started out with handheld scanning because they didn't have the budget for other technology, and then grew to add other technology, tripod-based scanners, other types of scanners to their toolbox. It's convenient. It's also very easy to use. It gives you high quality imagery. By nature, you're getting close to something. So it can be harder with more longer range devices to get the high quality data. But it integrates with the workflows of the other systems as well. So the data, and that should be, again, part of your toolbox should be to integrate with the multiple systems that are available, not just on the capture side, but as you referenced, even on the software side. So the data by itself, a point cloud is part of a digital twin, but a digital twin is a very broad term and means many things to many people. But the point cloud gives you the ability to capture in geometry the reality, the as-built at the particular time, and it gives you the ability then to use that data with other systems. So on the capture side, we should integrate with your tripod scanners, your GNSS if you use that for outdoors, and your aerial and your mobile capture systems as well. And then on the back end side, the CAD, the PLM, those kind of systems as well, all go into this toolbox of capturing the digital twin. But the ability to do it from a handheld device is just a very convenient and easy way to do it.
And then maybe I'll pose the question to you a bit more directly. So does a scan provide a perfect 3D model? And when and why should you stick to the point cloud versus maybe the CAD model?
The perfect, well, let me say, first of all, the point cloud is a 3D model. It's just a cloud of points that are creating the 3D model. And as you mentioned earlier, you can, whether it's annotations or intensity or other things that can be assigned to those points, you can assign some data to those points. But it's not to be confused with a CAD model that has intelligence that can be other intelligence, of course, the linking of PLM type data, the design information that goes into a CAD model. but the two can work together very well. But no, when you say a perfect 3D model, if a perfect 3D model means basically having all the information, it is not a perfect 3D model.
So myth number 3, and I think this is another really common one, is that, well, scanning only really makes sense for refits. Quickly, I think we'll get to debunking that. So first off, a great use case is equipment replacement and upgrades. So this can be a part of a refit, but it doesn't have to be, right? Design models might not even exist, or they're paper-based or out of date. And so modifications often go undocumented with kind of midlife equipment replacements or maintenance. And this is actually an NSRP project we're working on with DotProduct kind of as we speak. Ship handover. So another great use case for that is making sure that the owner of the ship has the as-built information. You can use the point cloud for the basis for 3D design, both for the start of a project, as well as refits, right? So if you're creating a follow-on ship, a sister ship, you can use that point cloud as a basis for 3D design. And lastly, for in-process engineering validation, that's another great use case. Brian, I think you'd like to touch on this ship check use case as well.
Yes. So one of the past NSRP projects that we worked with, I believe, SSI on as well, it was a number of years ago. In that NSRP study, we validated the use of handheld mobile scanning in ship checks specifically. And I'm sure we can provide the link to that study to anyone who asks, but it is that has been validated basically today. Well, it was validated a number of years ago.
Yeah, we're seeing customers use scans for as-built verification documentation. They're updating the 3D model from the point cloud, and like I said before, they're then updating the design model so that units 2, 3, etc. they don't have the same problems. And we're seeing this in use today already at shipyards. Myth number 4: scan data is only valuable to design and engineering. I think this is another very common misconception. So we'd love to get to the bottom of it. So if it's not design and engineering, then who can benefit from scan data? Yeah, feel free to jump in, Brian.
That's all right. I'll let you talk to this slide. Sorry.
Yeah, no problem. I think this is just a quick illustration of, well, how can scan data touch other departments, right? So scan data is kind of an in-between between engineering, but also between planning, production, procurement, and the owner-operator itself. The PLM system is often going to be kind of the best intermediary for that. So you need to feed that information downstream, and it can really be used by anyone, but it's just a matter of making sure that that scan data is accessible. And so we call that concept kind of liberating scan data. So yeah, like I said, many departments within shipyards can use that scan data for a lot of reasons. But because scan data is traditionally kind of in the design and engineering side, we need to make sure that we understand who took the scan and why. We need to make sure that the whole organization understands what does the scan support. And that said, we need to have a preferred storage location that is accessible and available to the whole organization. And that goes down to things like file name and convention, kind of preferred file type and things like that. And yeah, just generally what format should it take? So our opinion is that having a PLM system can act as the intermediary and answer those key questions for the organization. And actually, by liberating the scan data, you might see opportunities within the shipyard that weren't really considered for a use case for 3D scanning before, and kind of truly extend the benefit of integrating it within the whole organization. And a bit more specifically, so that reality capture scan data is kind of one of the last pieces of the digital twin, and we we think of it as completing the digital twin in a lot of ways. So from models to data to drawings and now reality capture, right? So really to have sufficient information to serve the purpose by which the digital twin exists, it is a combination of those things. And in many cases, that as-built data or as-is model data is the missing piece, and that's where reality capture comes in. So reality capture, like laser scanning, it supports this information with an overlay of the ship's configuration. And designers can use this information to identify what information has not been captured. And then later on, when we're talking about production, we can really see how what was built and how it exists on board the ship. And speaking of on board the ship, I think really interesting use case is actually outside of the shipyard and really in service on board the ship. So Brian, I think you're going to give us a little bit of detail about an exciting example of this.
Yes. So, well, first, let me say, too, that amplifying some and supporting some of the things you said earlier, there are multiple uses, depending on how you manage it, and PLM, I think, is very important to that, but uses of this kind of data. Where the current NSRP that we're working on in conjunction with SSI, we're looking at logistics and even fabrication. We're looking at trying to identify problems by scanning equipment before they try to install it, to compare it to the design. We're able to do this on tablet or at the desktop. And so this is a different validation study. We're going to be using different types of technology, different sensors, and looking at the capabilities to do that. So that's one area. As you mentioned, also the ability to to update the model as you go in a shipbuilding scenario, so that units 2, 3, 4 are don't run into the same problems. So we're certainly see the value in that, and we know that customers are using it that way. So onboard scan deployment is something that we see in conjunction with plant lifecycle data, or product lifecycle data, I should say. I use PLM for both. And we see the capability as something that it's inexpensive, it's easy to teach, easy to use. It could be used for inspection. I know from my old Navy days, the inspections are being done all the time. Back in my day with a clipboard and a checklist. And most importantly, it can be used to do damage assessments and optimize ship checks by getting data to the onshore engineers a lot sooner. If you have people already with this capability out at sea, they can be getting data to the onshore engineers and optimize and minimize perhaps the ship check visits that need to happen as well. A real world experience for us is, some of you may remember, the USS John McCain had an accident, I believe it was in the Sea of Japan, it had extensive damage. And at that time, we were all of a sudden requested to send a system as rapidly as we could over to Japan. Now, nobody ever linked the two, but I'm making just an assumption here that was because the John McCain was heading into port at that time into Japan. And to me, that was a perfect example of why wait? Why did you have to wait? Why do we, particularly now that the systems are even easier and less expensive to use? Why were we waiting to get that information to the people that needed to do the damage assessment and the repair planning? And I know in the Navy, reduction in time, the downtime for a ship is just critical. And so that to me is a real world example of why we should have that capability on board. And it's something that I'm confident, knowing the sailors that I know, they could be taught and they'd love it and be able to pick it up very easily on board. That's a Navy example, but it probably carries over to the commercial world as well.
So in summary, what did we debunk today, and what can we look towards for the future? So I think the key thing is to understand that, all of this can be done today. And it's actually not that tricky to get started. The solutions are already in place. We have the software, we have the hardware to make it easy. We've seen some examples of how scans can help at every part of the life cycle. But a key to that is making sure that scan data is managed appropriately, and that scan data is easily accessible in that same way. So those are kind of two sides of the same coin. And one solution that we've both talked about is that the organization can leverage scan data via PLM, and PLM is kind of can act as an intermediary for the whole organization for that scan data. So before we get to questions, as I said, you can drop your questions in the comments there, in the public chat rather, and we'll get to them. You can learn more about SSI by visiting our website. You can learn more about DotProduct by visiting their website. And after the end of the webinar, we'll have a separate slide there with quick links to some case studies and actually a link to this video done by a joint client of ours, KD Marine in South Africa. I think Gottlieb is actually in the audience today, so a shout out to him, as I think he's the one who's behind a lot of this. So I'll leave that video available for you to check out after the presentation. And so it looks like we have quite a few Gottlieb. Yeah, hi Gottlieb. We have a few questions here. So, and actually a comment from John. That is a very high quality scan. I think this happened while you were showing off the demo there. Then a question from Richie. So we never get our scans this clear. Are we doing something horribly wrong? Maybe you could share some tips there, Brian, about some strategies to get clear scans, or just in general, your thoughts.
So I don't know if they're DotProduct user. If they are, one of our blessings is also one of our difficulties is we support many sensors, and each sensor can have its own pluses and minuses. And so I would say it depends on the sensor you're using. It depends on the type of scene that you're capturing. And it depends on your workflow as well. So we'd be happy to talk to and help out Richie if he wants to reach out afterwards to see if there's anything we can do to help out there in terms of recommendations. This scan that was done that you're showing in the video probably was using at the time, I believe, one of our Gottlieb may know, one of our DPI units. For indoors, it captures the cleanest data still. It has other limitations, can't work outdoors, but I'm fairly certain that that's likely what they were using.
Gottlieb said yes to that, so I think your guess was correct there. We had a comment from Pete about, I think this was related to why haven't you gotten started with laser scanning or reality capture? He says the learning curve is steep. So what are some of those strategies to get past that learning curve and maybe take that first step?
So for us, we offer online training. Usually that's all it takes. We also offer in-person training. But most of our customers, generally when we're doing the online training, we have a quick start on our website to get you started very easily. And then we recommend that the customers start playing with it. And then it really makes the online training more focused on where they're having difficulties. It really is very easy to get started and use. Some of the professional features and the nuances of how to perfect your scan are a bit more tricky. And once you understand the easy part of getting started, it is also very easy to then train you on how to optimize your workflows.
All right. Doesn't look like we have too many other questions here, so I think we can end it here. Oh, actually, a couple more coming in. One from Zach. What happens to the photos taken during scanning and annotations once you export the scan? And maybe I'll expand that question to what, in an ideal workflow, what can you be doing with that kind of associated metadata as part of your project?
It's a very good question. First of all, you can export separately, but with their reference data, their positional data referenced in the photos and the annotations. We provide to our software partners with our latest DLLs the ability to access the information from the photos and the annotations from our DP file format. Unfortunately, most not yet have not taken advantage of that. So we're trying to push that more. Frankly, I don't have the list of those that are using the latest, and we'd be happy to provide that. But I know out of the over 30-something software companies that integrate with us, not all of them are taking advantage of capturing all that data through the DP file. So it is something that we're trying to work with our partners to be able to take advantage of, and like, for instance, be able to read annotations into their own annotation systems within the CAD environment or such. I know it's something we're going to be working with SSI as part of this MSRP, how we integrate the data into a PLM environment as well.
Yeah, I think we're really excited about the upcoming work in that area too, because like we were mentioning in the presentation, the PLM can really act as a source of truth for this and really liberate some of that associated metadata to the rest of the organization. So super excited about that. I think that's about time for today. We're running into the end of our scheduled programming, so to say. So I think we'll leave it here. For any questions that remained unanswered, we'll get to you at the end of the webinar. You can always access the recording or reach out to us individually if you want to review some of the stuff we mentioned today. Yeah, thanks to Chris as well for in the comments there getting to everyone's questions lives. And yeah, thanks so much for joining us, Brian. Your expertise is super valued here, and excited for the next time we get to talk about reality capture and laser scanning.
Thank you very much, and I really appreciate it, Greg, and we appreciate our partnership with SSI.
All right. Yeah, speak again soon.